On page 68. Page 68 in your math books. Problem solving strategies. Okay. Claire Michaels promised to bring 48 cookies to the fall party for 6th grade. Okay. She plans to make no-bake oatmeal cookies. How much peanut butter does she need? First of all, we have a recipe here. That blue square right there says that we'll make 36 cookies, and it uses 1/2 cup of crunchy peanut butter, right? So, the recipe makes 36 cookies. She needs to make 48, right? The recipe for 36 cookies uses 1/2 cup of peanut butter. Okay? We need to figure out how much peanut butter for 48 cookies, right? So think, how do I find a conversion factor to change from a recipe that makes 36 cookies to one that makes 48 cookies? Okay. What steps do I follow? First of all, we need to find the conversion factor and make a fraction by writing the number she needs over the number the recipe makes, okay? So, she needs 48. She has 36, right? So we made our fraction. Now what we're going to do here is we're going to change this fraction. We're going to reduce it down. What number goes into 48 and 36? Tristan? 12. 48 divided by 12 is 4. 36 divided by 12 is 3. Okay? Now that we have our conversion, we can multiply 1/2 times our conversion. Okay? Multiply this, cross out, and we're going to get 2/3 cups. Okay? So rather than needing 1/2 cup of peanut butter for 36 cookies, she's going to need 2/3 cups for peanut butter. Now, how long should she boil the first 4 ingredients if she makes 48 cookies? Well, it tells us that she needs to boil everything in the original recipe for 1 minute. So think about this. If I'm baking cookies and I have to change my peanut butter from 1/2 to 2/3, what happens to the amount of time that I'm cooking them? Nothing. Nothing changes about the time that I'm cooking them, okay? I still boil it for 1 minute. I still cook them for the same amount of time. I'm just making more cookies. Okay? How you cook them doesn't matter. It stays the same. Okay? If you alter the way you cook it, then you're going to burn the cookies or they're going to be raw. We don't want that. Okay? When you're dealing with a recipe and you increase it or decrease it, the time still remains the same. We don't do anything with that. That has nothing to do with how you make the cookies or the cake. You still bake it for the same amount of time. You still make this, okay, boil it. You still cook it for the same amount of time. What only changes is the amount of ingredients. Okay? So, let's look at problem number 1 here. A recipe that serves 6 people calls for 2.5 cups of flour. How much flour is needed to serve 9 people? So we're going to do this problem the exact same way. We're going to take and we're going to make it a fraction. We're going to make a fraction out of this. Okay? And we're going to put the amount served, or the amount needed, over the amount served. Okay? What amount is needed? We need to serve 9 people. How many recipes to actually serve? 6. Okay? Okay, so we're going to reduce this down and we're going to 3 over 2. Now that we have this conversion, we can go in and convert everything in that recipe. Okay? And we're going to do that. We're going to convert flour. We have 2.5 cups of flour. We're going to multiply it times this conversion. Okay? First thing we're going to do is we're going to take 2.5 and we're going to make that into a what?
2/3.
We're going to make 2.5 into what?
A mixed number.
It already is a mixed number. What are we going to make it into, Tony? An improper fraction. We're going to do that by multiplying 2 times 2 is?
4.
Plus 1 is?
5.
So we're going to 5 halves times 3 over 2. Okay? Can we cancel out? Can we cancel out? No. 5 times 3 is? 2 times 2 is? We're going to change this back into a mixed number. 4 divided by 15 is going to be 3. That's going to give us 3/4. 4 times 3 is 12, plus 3 is 15. Okay? A recipe makes 16 brownies, calls for 1/3 cup of nuts. How many nuts are needed to make 24 brownies? Okay? So we're going to do this problem the same way. We're going to put the amount needed over the amount served. What's the amount needed?
1/3.
How many brownies do we need?
16.
How many brownies do we need?
24.
24. How many does it make?
16.
16. What number goes into both 24 and 16? The biggest number that goes into both of those? 8. 8 goes into 24 how many times? 8 goes into 16 how many times? So we get 3 over 2 again. Then we're going to multiply 3 over 2 times what? 1/3 times 3 over 2. Okay? Does this cancel? Yes, it does. 3 and 3. Does this cancel? No, it doesn't. 1 times 1 is? 1 times 2 is? Okay. So you get 1/2. Any questions on how we did that? Any questions at all? All right, your homework for tonight is going to be on page number 67. Page number 67. You're going to do every problem on here except for section number 4. All right, this is a review of dividing fractions. So you guys can go and get started on this. Remember, when we're dividing fractions, we have to keep, change, flip. Keep, change, flip. Yes, sir.
Is the first one, like section 1, is that what we just did?
Section 1. Invert each number. The reciprocal of a number is the number turned upside down. So all you're doing in this section is flipping. Right?